Welcome back. Good afternoon. I am David Kuhn, and I'm a professor on the campus at Virginia Tech, and my degrees are in environmental engineering, and my research and extension programs are housed in the Department of Food Science and Technology. Welcome to the RAS Tech Virtual Summit. As you have seen today, this is a great meeting for producers, researchers, policymakers, and suppliers to get together to network and learn about RAS innovations. Thank you all for attending a virtual version of this event today. This panel session features leading RAS designers and technology providers who will be discussing today various innovations in recirculating aquaculture systems and land-based aquaculture, where and how the technology fits in ramping up the development of fully mature and successful land-based aquaculture industry. It is an honor to serve as the moderator of the session today. Now it is time to introduce each panelist one at a time. I will let each of them introduce themselves individually. Our first panelist in alphabetical order is Greg Beckman, the Vice President and Lead Designer at Innovasi. Please introduce yourself.
Good day, David. Thank you for having me. My name is Gregory Beckman, and I'm a VP and Senior RAS Designer with Innovasi.
Great, nice to meet you online. Our next panelist is Huy Tran, VP and owner of Aquatic Equipment and Design. Please introduce yourself.
Hi, my name is Huy Tran. I'm the Vice President and partner of Aquatic Equipment and Design.
Thank you very much. And our third panelist is Neder Snur, CTO at Aquamorph Aquaculture Technologies. Please come on the screen and then introduce yourself.
Yeah, hi everyone. My name is Neder Snur, CTO and co-founder of Aquamorph. Nice to meet you.
Great. So I guess the way we can start this panel is to have an icebreaker question. So let's get started with this first question. What is one piece of RAS innovation that you're each excited for right now? Neder, please start us off.
Yeah, I guess I am most excited right now about prospects of data analytics in general and machine learning in particular. I think we're able to do a lot more than we were in the past. We make use of much more sensors, imagery analysis, chemistry tools. We use IoT solutions to pour all the data into a common bowl and mix, and basically able to see a lot of this data on cleanse a lot of that data and see it on a common timeline. I think that immense amount of data that we gather, we really need those tools to be able to process properly. We can't do it using just the human capacity alone. So I think these tools get me really excited to start using. So yeah, thanks.
Thank you. And Greg, what are your thoughts?
Yeah, so to echo a little bit of what Neder said, is what I'd see, especially within our group, is the rapid advancement of the automation and control functionality of RAS systems. I think long ago were the days of using a valve to control flow. So I think a lot of the panelists in some of the earlier presentations touched upon finding good operators, and that was an area that they need development of, is good operators of RAS systems due to the complex interdependencies of the operation. So we feel that the rapid advancement in this area in terms of biomass estimation, automation of pump controls, leads to a little bit less human operator needs and a lot more standardization in the operations, which may offset a little bit the needs of these high-level operators that are a bit not in demand right now. So.
Thank you. And Huy, your thoughts on this?
I definitely echo my colleagues' opinion, but I also think the use of ozone and the better understanding of use of ozone is really important as our densities is increasing and our production is increasing. But I think one of the other thing is I really like to see that on the human factor side is the level of understanding of RAS in your husbandry staff is much greater than what it's ever been before.
Thank you. Now, we all live in this unusual time with this pandemic, and so I think we should definitely talk about that a little bit. Um, let's start with Greg this time. What challenges have you experienced in regards to supply issues caused by COVID-19?
Yeah, so I think that's a threefold answer on our side. So obviously, there's been a few projects that were planned that have started delay of construction, mainly due to travel restrictions and the like. There's been some level of interruption in equipment supply, less so than we anticipated, because many of our suppliers that we partner with are classified as essential businesses. So the impact that we thought we may have seen there has not been what we expected. But the bigger one, I think, that we've had to or work on is we've had 4 to 5 implementations of startups of systems that we're no longer allowed to travel to. So where we normally put a person on site to go through startup commissioning and training, we've had to do that all remotely. It's posed some challenges, but certainly the use of new technologies, FaceTime, WhatsApp, our ability to log into our control systems to do setup and commissioning through the data stream and the control aspects have proved to be more successful than we might have anticipated. So we've had some good startups without being on site. So I think that's the 3 areas that's kind of impacted us primarily.
Yes, I can imagine that's the case. I'm trying to train grad students right now, and it's a whole new ball game, because typically you go in there and you hands-on, side by side, showing people how to do it. So Netter, I know that you do a lot of international work as well. How have you adapted to that, the COVID-19 world?
Well, actually in a similar fashion, I think we all have to. So it's really through all project phases where we need to support the teams on the ground, through construction, commissioning, and ongoing production. The main objective, of course, is to support these teams and provide all the knowledge and experience that we've gained over the years. I would say typically through 3 major project milestones, which is your project construction and commissioning and your customer support later on. And it's during the construction phase, there's really a need for daily participation through inspection tests of the construction on site, other construction activities, resolving issues, leading design reviews, installation of key components, technology components which have to be installed. Later in the commissioning phase, everything needs to come together and starts to breathe life. The individual components are tested, and then the whole system is tested, and we begin pre-stocking activities, which include disinfection, biofiltration, maturation, etc. And then customer support, of course, later on to make sure that the knowledge base is sound. The people know what they need to do, and then make sure that you're able to train. What we've basically done, since it was clear to us from the beginning that we had to be able to support a lot of projects around the world. And we knew that it would be a challenge. So we were kind of prepared, so to speak. But it really gave us a push, and we understood that we really need to expedite this process. We couldn't wait as long as we thought we could. So we basically started to implement. We put together a task force really to look at what existing technologies were out there, what's emerging in terms of customer support, expert support on the ground. We make use these days of advanced tools like smart glasses or other applications that allow us to be as physically on site as possible without being physically on site. And I think it's really really interesting and encouraging to see what we're able to do from so far away, and how we are able to transfer a sound amount of knowledge to the people who need it. And then, of course, make sure that it's documented properly and generates SOPs and best practices.
Thank you. And Hoy, what has your experience been the last 6 months?
Yeah, that same as everyone else. Our biggest problems are supply chain, of course, capital at a time where capital is not flowing or moving all that well, and of course not being on site and visually seeing the project as it progresses. It's definitely a major undertaking. Although nowadays, with the remote water quality and stuff like that, you can actually give feedback to your clients relatively easy, and you can actually help set their controls. So a lot of the challenges has also put innovations to our industry for sure.
Thank you. And where do you see things going in the future? I mean, I guess we don't really know, but do you see things improving now? Or I know I'm seeing some areas of the economy improving. Are you seeing improvements or a trend that way? Or what's your prediction? What's going to happen?
For us, I think we see a lot of innovation just because they have to overcome these periods. Just even some simple stuff like web marketing, how they go directly to our clients, going directly to the end user or the end consumer versus going to a middle supplier or anything like that. So I think that's a little bit easier. It seems to be a little bit easier for the medium to smaller farms. The bigger farms, that's really not our forte per se, but it seems to be easier for the smaller guys to kind of shift. The larger guys are doing it, but with the volume that they're putting out, it's a different challenge.
Thank you.
If I can follow on that, Dave, you see that we're starting to see some of our clients come out of that. We've have 3 construction processes or facilities underway now. All 3 of them went into a bit of a stasis in the middle of construction. They were impacted by COVID. Some of them were highly dependent on the the food service sector for their product. One of them had a 70% reduction in sales, nearly overnight. So they're all coming out of that now. So they're actually started restarting construction now. So for all 3 of them actually. So we are seeing that they're putting their capital back into finishing construction.
Oh, Netter, do you have anything else to add in which you think things are going in the future?
Yeah, so no, I just wanted to say that I feel very, very fortunate that we have the client base that we do, which are really standing behind their investments and pushing forward to looking at the big picture. Obviously, things have changed, but we'll adapt like we always have, and yeah, very, very excited to see this.
Yeah, it seems like a lot of the major interruptions are kind of settling out across the different sectors of business. So hopefully that remains true and we can proceed with business as usual soon. The next question is, what's the most important thing about production planning? There's, and what important aspects of design and engineering do you think is most overlooked during production planning that leads to failures or major issues once production starts up? We'll let Greg start this one, please.
Yeah, so I mean, from our perspective, production planning is really the #1 goal that needs to be achieved. Everything else kind of is based off the outputs of those things. So it's an interesting process to go through. Some clients will come in kind of with a concept of a bio plan or a production plan that we work with them on. We get a lot of people, not the big players, the people that we've seen on the early panels, but in the smaller players, you might get a person that comes in with a building full of tanks and no room for filtration, and you inquire what their production plan is and the fish movement, and they kind of give you a blank stare, virtually. So I think it's the importance of that is, if you don't have that, a good plan to move the fish in, through, and out of the facility where you're not going to have either fallow tanks or bottlenecks to not be able to bring fish in, is really the main key ingredient to making a facility even remotely capable of prospering. So the second part of your question, I think one of the things that's really overlooked in a lot of production planning or facility planning and people we talk to is fish handling seems to come in after the fact or way down the line in production planning, and that sometimes causes a large issue to what may have already been developed or put in place to then try to retrofit that in. So I think fish handling aspects is, is a key ingredient in design up front in the facility.
Yeah, so how you move fish from one production area to another with biosecurity in mind and all that.
Correct.
Yeah. Have you seen any particular innovations in engineering technologies that move fish or shrimp that's come out in the last couple of years or anything?
Well, I mean, it tends to be a trend in the larger salmon facilities producing the bigger fish to not want to pump fish or to reduce the pumping of fish after a certain size. So that, the inclusion or the use of swim channels is starting to gain momentum to reduce some of those pumping distances. There are some challenges, I think, there with some of the enumeration and counting of fish and potentially grading completely in swim channels, but they can be used in conjunction potentially with pumping and grading.
Thank you. Anything else to add, Hoy or Eder, to that effect?
Yeah, I mean, from my perspective, I think while I agree with everything said, I think it's fundamentally important to begin with identifying potential hazards in any site, and I think biosecurity engineering is something that needs to be a high priority whenever we start designing any kind of system anywhere. So identifying your potential vectors of hazard or potential disease or pathogen coming in, and then accordingly define the means of protecting your system, whether it's a certain level of filtration on the air intakes or any kind of system disinfection or intake disinfection. So I think that's really key. And then, of course, as Gregory said, moving fish handling is really, really important, and it is important to minimize. On the other hand, it is very important to keep the flexibility and be able to move and manage your biomass. The more capabilities in moving your biomass you have, the lower standing biomass you can handle for the same yearly production. You need to handle for the same yearly production. So it really helps to be able to move your fish around and do it without stress. I'm personally an advocate for swim channels, for we call harvest channels. Other than that, I think energy is going to be also key moving forward. It's very important to remember when we talk about energy, a lot of people talk about the energy required for running the process, the main process of water filtration. Some include oxygenation, some don't. But the important part to remember is that all of that energy, we are in a closed system, so all that energy eventually will end up as heat. So when you allow yourself to be lenient on the amount of energy used, that you're going to pay twofold. You're going to pay once for running your process, and then another time for cooling down your water, if we talk about cold water species like salmon. So I think the importance of making sure that you're really cutting every unnecessary kilowatt of energy in your process is really important.
Thank you. Hoy, do you have anything else to add?
No, I think everything is covered pretty well. The only other thing I would say is water source. You have to select the site with a decent water source. We've done project where they had to dig through granite, or they had to bring in city water to treat. A lot of that stuff just doesn't make any sense. So that's a really big issue for some of the project that we're seeing now too. They think about the system, but the source of the water is sometimes not thought about. So I think that's a consideration for sure.
Absolutely. And I've seen issues in the past where they have good sources of water and then no place to dispose of it.
Discharge.
You have a marine system and you want to dump it down the drain in a small town, you're going to run into problems. Going on to the next question. want to move this along because I see a lot of questions coming from the audience, and I want to ask a few questions first. What are your general thoughts, Hoy, about and how do you guide in the design process whether you use aeration versus oxygen?
Yeah, I think, realistically, when we're talking about RAS, we really should be talking about oxygen versus aeration. We get that mistake all the time. The only time I really kind of recommend the aeration is if they're doing the aquaponics or the hydroponic component of it. We recommend aeration as a means of aerate and circulate versus just oxygen. But with the density to make sense for the return on investment in our system, really should be using oxygenation.
Any other thoughts on that, panelists? Does that pretty much cover it? That topic?
The only thing maybe I would add is that when we evaluate the efficiency of aeration versus pure oxygen, would be when we want to run such processes as suspended solids filtration, or other processes that do not require high oxygen content in the water, and many times those processes would benefit in terms of electric use from air, because air provides more agitation and is efficient to transfer oxygen when oxygen content is low or concentration is low in the water. When you need to maintain 100% saturation of oxygen in your tanks anyway, it won't help to add air. You're not going to go above 100%. So it really is important to use pure oxygen for RAS applications, and not to, well, unless you have an extreme amount of flow through your tank, which is going to cost a lot more, on energy then. But typically, yes, I would say avoid using air for high density RAS.
So when you use air and high density RAS, this is a question to all the panelists. Do you ever run into problems with CO2 buildup in that system because you're not off-gassing enough CO2 when you use oxygen? What have you observed?
When you use oxygen.
Mm-hmm.
Right.
Yeah, I mean, any high density system. Go ahead, Derek.
Go ahead, Greg.
Great.
Yeah, to follow on, I would say if you're maintaining, we go through this analysis with clients quite a bit. You talk to them about maintaining a particular DO level in the tank, and then they think the water coming back is super saturated, and they have that value until you explain that you don't want zero, you don't have that value, you have what you need less the value you want. So to all the points being made, you definitely need the oxygenation. Most all systems using oxygenation are going to have some level of CO2 treatment within the treatment package as well. So.
Thank you. And what are your thoughts on using ozone, freshwater versus marine? There's some questions coming from the audience about the use of ozone. And I know in freshwater, you're looking for certain things, and in marine systems, it's a little bit different. Could you start us out on that, Greg?
Yeah, so we typically use ozone in almost all of our systems where it makes sense to do so. Freshwater is a little bit more straightforward. Obviously, than in seawater, where it rapidly decomposes into other forms, bromide and bromate forms. So yeah, we look at ozone as a multi-effect applicant. Reduces any residual nitrite, residual color, microflocculation to solid. So yeah, I believe it's something we routinely use on almost all of our systems. So we do believe in the use of that. There is a little bit of maintaining that in salt water and testing for free and bound or total bromine, and the effects of which one's got a reactive value versus the bound bromine that doesn't have as much reactive value. So, and then potentially the long-term accumulation effects there. But for the most part, we've had good results without any toxicity issues in saltwater systems with ozone.
Thank you. I think you summarized that well. So I'm going to read a question here. It's about feed. Well, first of all, let me just get this question out there. Obviously, when you feed fish in a RAS system, it's very different than in ponds or in cages. So what are the types of differences that you've observed? What kind of changes have to be made in the feed formulations, the stability, the physical aspects of it? Is the RAS industry integrated enough with the feed companies to to make sure the feed's designed properly? What are your thoughts? This is open to anyone on the panel.
I think the RAS industry is pretty integrated with the feed industry. So there is a difference between pond quality versus, regular pelletized feed that we would use in our RAS. Is there room to grow in that? Absolutely. As our species expand and as our systems change, yeah, there's definitely places where the feed production can kind of meet up with RAS more. But I think the stability of the feed is important in our RAS, and also the formulation has to be correct where we don't have so much waste byproduct that's not being consumed and going into our filtration and clogging that or causing problems for that.
Thank you. Any other thoughts on feed management? How does it differ in a RAS facility versus other aquaculture production systems? In terms of management feed, how do you deliver the feed?
Right.
Yeah.
I think the way you deliver the feed really has to be tailored to the system and the fish you're growing. Some of them would prefer consuming, a trickle of feed continuously, and some would prefer more of a batch type feeding to, allow more of the population to have access. Some of them hog the feeder. So you have to really know what fish you're feeding and how to feed it. So I think in that respect, the feed itself, in terms of formulation, has much more of an impact, obviously, on our systems, and the closed systems. The more closed they are, the more impact it's going to have, and it's going to have time to any uneaten feed or feces just as well would remain in the system for a very long time, especially systems that make use of processes such as suspended solids filtration, using or extracting the carbon source from the waste of the fish. That waste needs to remain in the system and digest for a long period of time. So it needs to be very stable. And of course, the worst thing you can do is leave uneaten feed in the system. So you need to really make sure that every single pellet is fed to the fish and consumed properly. Yeah.
Thank you. And to the same feed track line here, the last question for this area would be, there's all these new technologies, new softwares, AI, all this stuff. Can we use any of these new technologies to help us with feed management? Are there any innovations there?
Yeah, starting to see a level of automation in that. Some of the work Nova Sea is doing in the net pen culture with bioestimation, hopefully make its way into the RAS systems where the automation can basically do real-time biomass estimation versus batch samples of the fish over time, and tie that back into automated feeding, so that you get that daily feedback instead of a weekly, biweekly, or even longer period of time between your biomass estimation and your feed adjustment. So I do think that is certainly on the horizon to become much more automated, even more so than the automation that's already there today in terms of feed programming, to get the real-time biomass aspects to adjust that feed versus from a feed table or periodic batch sampling.
Great. And then I have two more questions about feed, and then we'll switch gears a little bit. The question is, what is the feed percentage you follow in RAS? So I guess how does it differ from other systems? This is an open question.
It really depends on species too, and the stage in which your organism are being held. So that's kind of a loaded question. So, but it is tend to be a little bit lighter because the feed efficiency is much better because you're in a captive area versus a pond culture or a raceway. But it's very species and stage of development dependent.
Add to that, David, quickly?
Yes, please do.
I would just say, if we're talking in the context of designing systems, it is very important to make sure that when designing a system, you have to assume a certain load of feed. and you really need to be responsible when you select that assumption, and make sure that you've gone through all the potential bottlenecks, so that if you do need to feed more feed, you'll be able to handle the resulting CO2 or generation or oxygen consumption, or heat load, or anything that any one of those bottlenecks you would sequentially go through when you change one of these factors in this circular reference.
That's a very good addition. Thank you very much. Another question is regarding feed. Is anyone concerned about GMO feed content? Whole Foods is ready to require non-GMO feed content for animals, according to this question. Any thoughts on GMO in the feeds? That's a tough one.
Yeah.
That might be outside the discussion of design and engineering.
I think, I mean, in general, I think that I don't expect that we would, even in the future, I don't think we would be adjusting our designs according to that criteria.
Right.
Not that I know of.
Yeah.
Yeah, I just touched upon what the others said. You know, we tell clients, and if we're doing the work, when you come to RAS Design, if you're only going to get one number right to give us, make sure it's the feed number.
Yeah.
That pretty much drives all the other calculations. So that's the main important input. I mean, there's lots of important inputs, but I mean, feed is obviously a driver of most of the calculations for the system requirements. And obviously, as we said before, you know, the stability of the feed particle, make sure the uneaten feed can get to the filtration system before breaking down. And the effects of a lot of work is being done with RAS specific feeds. I mean, they are actually making RAS specific feeds nowadays, many of the suppliers. And there's some stuff in there to, you know, there's a lot of species that have a looser fecal material, which can make it a lot harder to, on the filtration system to remove. So some of these feeds are generating to, you know, bind up the fecal materials to make them easier on the system. So I was once told, if you want to kind of think about this in context, if you feed your dog really good feed and versus really bad feed, and you look at your backyard, that's a way to kind of think it through.
Yeah. Yeah, and I think with the whole feed, with all the ingredients that we have, to switch to a feed that is non-GMO, I think that's a major challenge. There's another challenge that's just right in front of us, is dealing with the amount of phosphate that's in feed. So, you know, there's so many levels of that right now. And, you know, we get clients every now and then that always wants to formulate their own feed. And I kind of laugh at that. I said, do you know the nutritional needs of each species and at each stage, and you want to formulate your own feed? You know, it's just not, at this point, not realistic. But in reference to RAS, it really doesn't make a difference what kind of feed they use. We just have to know the amount and then the type of waste that's going to be produced for us to do the filtration or the life support needs for those the organism.
Thank you. Do you all probably apply a factor of safety in the calculation as well for the design of the biofilters?
Yeah.
That's always
rule
smart.
Rule of thumb.
But don't tell anyone.
Yeah.
That's right.
We won't go into details.
or they'll use it immediately.
That's right.
We have a couple questions about fish welfare, switching gears here. So I'll read one of them to you. Considering all the novel opportunities we have with RAS innovation, how can we use these to further improve fish welfare to ensure future-proof operations with minimal mortality rates? So the bottom line is, how can we use RAS innovations to help improve fish welfare?
I think the advancement in being able to score the fish in terms of welfare indicators in situ is going to make a big difference. So things like stereoscopic cameras and video monitoring of the populations would be able to enhance our understanding or insight into the animal welfare situation, and allow us to also act ad hoc when we see any kind of indicators that may be troubling. So I think that there are multiple multiple KPIs that we can look at that would lead us to the conclusion of, yes, are we in reasonable welfare conditions compared to the industry as a whole. And in general, my own belief based on what I've seen up till now is that if we actually look at things like Fin's score at percentage mortality, percentage issues with disease in RAS versus farming in cages, for example, this is my opinion, this is not backed by any science, but from what I've seen, I think we will see better welfare in well-managed RAS than we do in a lot of cages.
Thank you. And then I'm going to do one last question from the audience for one of you to answer. UV versus ozone and RAS. And then then after this, I'll give everyone one opportunity to give some closing remarks, each one of you.
Yeah, I think there's plenty of information out there. You know, when you get into big systems, I think there's a CapEx element and an OpEx element to employing both. I think there's enough research out there that shows that obviously the combination of the two is has a much higher efficiency than either or being used individually. And most of the recent work I've seen is, you know, that ozone is slightly more efficient than UV from a bacterial standpoint, anyways, if employed singularly. So.
Thank you. And I guess I'd also add that, you know, if you have a lot of particulate matter in your system, UV is not a very effective. And I would imagine ozone would do a pretty good job breaking down turbidity. There's a question about that as well. Okay, so now let's go to closing remarks. We'll go in the opposite order that we introduced everyone. Netter, go ahead. Closing comments.
Closing comments.
Last minute thoughts or?
No, just very excited to see all of us come together and discuss these topics. I think it's really important, and I think in general our knowledge base needs to grow. We need to be able to share what we can. Obviously, we're all in this, or not. Most of us are in this for making profits for our companies, for advancing our companies. But we also can mutually benefit from disclosing certain information. I think it is very important to identify the interests and do that as much as possible.
Thank you. Roy, closing remarks.
Yeah, I think the flow of information, the exchange of information is very important for us to grow the industry. And like we joked about earlier, we have kind of a rule of thumb to size biofilters. If the client would give us the correct information and the information that don't undersize or underestimate what you're going to do, that would help us to progress and make sure that you have the right system, right design.
Thank you. And Greg, final comments?
Yeah, from a global perspective, we all talk about food security. We talk about feeding the world. I think that RAS is going to be is going to be a large factor in implementing that goal. I think it provides you with the optimal water quality conditions where some of the other growth mediums don't, cages, ponds. I mean, you got some environmental factors that are hard to control in that. And just the ability to place these things, close to the markets. So reducing the carbon footprint for transportation, food security, local food security. So I think RAS is going to play a huge role in that. I do think that there's still a lot to learn. I think obviously the big players are growing and working to prove out their cases that large RAS will work. But in the end, I think this has got to be a growth industry for all concerned, and that we should all be working towards a common goal of making it economical. Because as you say, we can grow anything, even if something that's not being cultured now. We know that we can probably grow it, but obviously you got to grow it and make a profit. So.
Yep. Thank you, Greg. And I apologize to some of the audience in that we have not answered all the questions. There's a lot of good questions, a lot of detailed questions that we could talk about this all afternoon and have some fun. But we are ending this panel now. Thank you to all the panelists. You did a great job today. And now I'm going to turn it over to Mary Lynn.